everyone, and welcome to the ASUS AIoT Podcast. Today, we are very honored to have Raul Bravo here with us from Outsight AI. Raul, you are an expert in 3D spatial intelligence, right? Can you explain to us a little bit what your technology does, and then we'll go into some questions about you.
Okay, so when you say spatial intelligence, that means what? That means being able to gather and understand the physical world. And the physical world, that's why you use the word spatial, it's 3D. Mm-hmm. 3D means that you really know where things are, how far, how big, how quick, how they're moving. So all this, it's related to how things are in the space, spatially. That's 3D. And intelligence or spatial intelligence means gathering or getting insights out of that. So things, information that you can really use in your operations. So that's the general, let's say, concept. And that's exactly what we are doing. We can get into more details just afterwards, but it's making this available, making it usable.
Okay, good. We'll talk a little more about the technology, but let's start with you. So tell us a bit about your background. Do you have a technical background? Have you always been in technology?
I have been always with two legs, let's say, one on business and one on technology. So yes, I'm an engineer by education, the Polytechnic of Catalonia, telecommunications, but at the same time MBA, and having created several companies, several startups and scale-ups in different fields, but always technology, and in many cases related to similar problems, which are more understanding the external world for computers or for gathering and this information.
Right, and this is the space where we were brought together, right? So we were introduced because we are trying to deploy solutions that are connecting the physical world, digitalizing that data, and doing something with it, right?
Exactly, and the natural reaction of someone, a smart city, a venue operator that want to do digitizing the physical world. Today, they mainly know about computer vision solutions, about the solutions you can empower. They don't all them know that there are new technologies that are specifically designed to capture this kind of data.
Yeah. You are right, because when we think of monitoring and this real time in order to understand physical situations, we often think about computer vision, right? But as we know, there's many limitations to that, because first, the amount of processing power that you need, and not all of these data that we're gathering is useful. But I have to confess that when I first heard about LiDAR, your technology, I was like, well, but isn't LiDAR very expensive and also used very specifically probably for autonomous driving? What is Outsight AI doing, and how efficient are they?
Yeah. Well, there are two things. So if we look at the first of your feelings or initial feelings on using computer vision, what you said is right. It's power hungry, it's complicated, etc. But I would even go backwards and in a more fundamental issues is that you are trying to capture the physical world, which is 3D, with a sensor which is 2D. That's the beginning of your problems with computer vision. It's not the other consequences are only consequences, but the cause is that you're trying to capture a 3D data with a 2D sensor. And that's the first problem. Second problem is you're trying to capture 3D data of the real world. In the real world, it's moving also when it's in the evenings and the nights, so you don't have light. It's also moving when it's raining. It's also moving, so the physical world is not very compatible with a 2D sensor that relies on external light. So the LiDAR sensors are bringing 2 or 3 new advantages. One is that they are active, which means that they don't need light because they are generating their own laser light. That means it works in any lighting conditions. Second, it's 3D. We have already talked about that. So they're getting the actual data you are interested in, where things are, how they're moving, etc. And the third, which is a consequence of this being a new modality of sensor, is that we are not capturing images. So that means also that from the privacy perspective, we are never gathering at any moment any identification or any personal information. And that means that it's natively anonymous,
right?
Which is different than anonymized.
Yes, exactly.
Anonymous, it's not the same. Anonymous means that really you are not gathering. That's, by the way, why if you are looking at LiDAR data as a human, you don't understand nothing, because it's really not possible to get insight without the software. And that's exactly what we do. The software that is taking this unique new kind of data and making it usable. And what you mentioned is very important, because there is a feeling, or which is less and less the case, that LiDAR is expensive.
Right.
And yes and not. LiDAR is still expensive for cars.
Okay.
It's still expensive for cars, even if the prices have really decreased.
Yes.
But it's not exactly the case for infrastructure operations as are our customers, operators of infrastructures or venues, for several reasons. One important reason is that the kind of LiDARs that we are using in infrastructure are different and can be built much cheaper.
Okay.
So today you have LiDARs at 300 euros, which is not so expensive. Yeah. They exist. And then second is that the problem you're trying to solve when you are an operator of infrastructure is not the same as when you are building a self-driving car.
Right.
When you are operating an infrastructure, you have thousands of square meters that you want to digitize or you want to monitor.
Yes.
Yeah. And you don't really care as an operator what technology you're using, LiDAR, camera.
Yeah.
What you want is getting the insights of what's happening. But it happens that from the technical perspective, LiDAR has also an advantage, is that can cover much wider surface, which means that for the same square meters, you're going to use between 3 and 10 times less sensors than cameras. And that it has a double effect. The first one is, of course, the cost of the sensors overall for a certain surface is much less, but also the installation, networking, processing, maintenance, all these costs that are hidden in the data sheets of the manufacturer because they are selling the equipment, but the cost for the customer
sometimes it's higher.
It's much higher, in fact. In some cases higher than the device. So that means that at the end of the day, our customers in airports, for example, they are seeing our solutions being cheaper or at least competitive with computer vision technologies that they are already using with a much better performance and specifically with features and values that they cannot get with cameras. For example, something that we are able to do today, which is a basic, or not basic in the sense of easy, but fundamental, foundational, let's say, capability, is that in an airport or train station or venue, we are tracking every single individual over the whole premises, the whole airport, which could be hundreds of thousands of square meters, etc. Every single traveler, thousands of people simultaneously, all of them. This is not possible with cameras.
Right.
Is it possible in very simple use cases like one intruder?
Yes.
For security applications, you can track one intruder more or less.
Yes.
But this scale of tracking so many people, movements, and interactions is unseen in the computer vision world.
Yeah.
So it's much cheaper and not more expensive, much better in sense of performance, and able to do many more things that were not even possible to see with cameras. And when I'm saying more accurate, sometimes we say, yes, it's a technical thing. It's always engineers willing to do better. It directly translates into business for our customers. For example, we have a very interesting customer which has one very known tourism place. We are going to be communicating very soon. But anyway, it doesn't matter so much who it is, but it's very known. And they had a ready camera solution. And because of this solution not being accurate enough, they were obligated to respect a certain number of people, that affluent people entering the tourism and they were not able
Yes.
to be precise enough. So they were not letting people enter. So business that they are losing.
Right. That's the opportunity.
Because of not having an accurate solution. So accuracy, it directly translates into business at certain levels of accuracy. If you're not good enough, it's just useless. In many applications, 90%, 92%, 93% is the same as zero.
Right.
Because it's not something you can use in a very actionable way in some cases.
Right. Okay. And I think that I wanted to ask you a couple of questions, but we answered them because basically it's what kind of pain point are we trying to solve here? But you said, a lot of the traditional ways of doing this monitoring was either costly or not accurate. So you are able to solve these pain points with your technology.
Yes, that's our let's say, inconvenience of drawbacks of the technology today, computer vision.
Yes.
But the pain points we're solving is mainly that operators of infrastructure, they need to understand the flow of people or vehicles.
Yes.
If they don't understand that, it's very hard for them to optimize the process, to be more efficient. It's very hard to them to really have impact on the passenger or visitor experience because they don't know where are the problems,
yes,
or what you need to solve.
Yes.
It's also hard to ensure safety and security if you don't know what's happening.
Yes.
So the pain point we're solving is that we are at the core of the main issues that are critical for them.
Yes.
And they don't have solutions.
Right. That's true. And coming to the point of ASUS, how we met and why we met, really, the collaboration. Can you expand a little bit for the audience how we collaborate in this case? How do we adopt your technology or help promote your technology?
Yeah, so I would say that you as a company followed the same kind of thought journey of some of our customers. They were not necessarily naturally thinking about LiDAR, saying this is too expensive, it's for self-driving cars, etc., etc. So it's at the time when you're aware that there is something that can be done today and not in the future.
Yes.
Today, then naturally you're very well positioned to leverage this technology with us in creating either smart city solutions, transportation hubs solutions, venues, etc. So we are in the same kind of markets.
Yes.
And again, computer vision is something you know very well.
Yes.
You're enabling. It is going to be there. It's not disappearing because of LiDAR.
Yeah, but it's complementary.
Yes. So that, I would say, is natural that we finally met.
Yes. I still remember the moment when one of our partners introduced, because they know us and they're part of our partner program. So what we do in the partner program is basically build this community of different solution providers that will be able to create solutions that are more or less end-to-end and recommend each other and go to projects together. So we will do this whole journey of creating, going to market and deploying eventually. And I remember when this partner told us, you have to meet these people. They are doing amazing things, 3D, real time, what computer vision cannot do. And because I come actually from a computer vision software background, I was like, really, I completely could see, these holes that computer vision couldn't resolve. And said, are they doing that today? Amazing. I need to meet them. I still remember.
Exactly. But that's a good example of also who we are and what we are doing is that we have also a DNA of partnership. Because as you can already see, our technology is very horizontal.
Yes.
So can be serving many different needs of different markets, different verticals. And there is not a single company that can deliver to all end users in the world in different verticals. So you need to partner with system integrators, and that's how we met.
Yes, exactly. Yes. And now I think that maybe give us an example, one or two examples of deployments that you're most proud of or projects you're working on that you're most proud of. And you can also go into a little bit of a deep dive, or if you want to specifically mention what your technology can do.
Yes. So if we already talk a little bit about the needs we are resolving or we are answering to, which is understanding the flow of people and vehicles in premises. So we can take two examples. One is people, and the other can be on vehicles, or several of them.
Yes.
If I take the example of our capability to track and monitor people, one of the best examples are airports in general. Why? Because airport is almost a small city.
Yes.
We're going to give an example of a city afterwards, but in airports you have many problems. You have security problems, you have retail zones, you have transportation, etc., parking. You have many problems. Yes. So that's why airports, it's a good example. So what we are doing for airports, but the same thing for rail stations.
Yes.
It's
transportation hubs, right?
Transportation hubs is in a general word is digitizing the movement of people, which means delivering to different kind of users, because between the airport there are different needs. Okay, but in the common point is giving them the KPIs that are directly usable in their operations.
Yes.
So even if I'm explaining that from the technical perspective, we are tracking everything, everyone, everywhere, this is not directly actionable. It's too much information for a user and end user. So what we are doing is, thanks to this granular information, we are aggregating, condensating in KPIs. What are the typical KPIs that an airport is interested in? First, for example, is the queues. We are automatically detecting queues, saying, hey, here, specifically here, not the whole airport, here, there is a queue that shouldn't be there.
Yes.
And the queue length is this size, the number of people in this queue is X, the waiting time of each individual, because queues are complicated. The waiting time from the first one in the queue is not the same. It's not the same as the last one. So if you make a kind of approximation, it's not very useful.
Yeah.
It's better than nothing, but it's not very useful. But we have the information of everyone. So we can deliver and aggregate, saying, okay, the worst case, first case, etc. And this is directly actionable for them. How they can use this information, there are mainly two ways. Either they need to react immediately. For example, because it's a safety or security problem.
Yes.
It shouldn't be too many people at that point if something happened, for example. Or another way to react is, if I have these queues in the check-in, I'm going to have it 20 minutes after in the security.
Exactly.
So I need to adapt my process. That's an immediate way to use the information.
Yeah.
Another way to use the information, which is complementary, is I'm analyzing this over days, over weeks, over months, to understand what are the patterns, what is happening at what time and why. So I can, for example, optimize staffing depending on the demand, depending on what's really happening in real time or over long periods of time. But different ways to digitize, to use the digitalized information of the flow of people. So there are tens of KPIs that airports are using, and all of them are based on our capability of tracking everyone all the time. So that's an example. Another example in the terminals on airports is the usage of resources. For example, the automatic self-checking machine. How long it is used, how long between one user and the following, etc. So that helps to understand if there are enough or not, or is there a problem. It's a level of insight that is
very accurate, very precise.
Very precise, and many of the use cases, because there are dozens of use cases, some of them are very, very valuable for the customer, and others would not justify deploying an infrastructure only for that.
Right.
For example, we can deliver information of how long, how often restrooms are cleaned, etc. This can help on optimizing the process. Would you deploy an infrastructure only for that? Probably not.
Yeah.
Because the economics are perhaps not.
Sense.
No. But if you have it, because you have already deployed the infrastructure, which is being used for many valuable use cases, this information, you have it also. So you can use it. So it's a platform. That's why we call it also a platform. It's not only one use case. There are many, many use cases. Another example, in a different world, let's say Bellevue City, close to Washington in the US. They deployed a solution to make a smart infrastructure, a smart intersection. To do what? to understand how vulnerable road users that are pedestrians, bicycles,
Yes.
were having events like near misses. Near misses meaning a situation that is not an accident, but close.
Right.
For example, a car which is just braking in front of a cyclist. It's not an accident, but the cause that generated this situation, if you don't change it, sooner or later, it's going to become.
Yes.
So you need to, so they used our solution with LiDAR to monitor all these events in order to take action.
Yes.
They monitored, they understood where and when these things were happening. And by the way, it was many of them happening on the evening. So remember when there is not so much light.
Yes.
So things that you would have missed with cameras because there is no light, etc. And then they took action of better paintings, better signalization, etc. And they keep measuring.
Right.
And there was a difference of close to 90% reduction of these events.
That's a lot.
It's a lot.
Yes.
So if you have the objective of the Vision Zero accidents, that's super concrete. You know how to avoid accidents because you are understanding what's happening. At the end of the day, it's everything the same thing. It's because you are understanding what's happening in the physical world, you can take action.
Yes, exactly. Very good examples. I think that we also delved into the technology side of it. Where do you see this technology and your company going in the next, say, 5 years?
Yeah. Today, of course, the technology is relatively recent because the prices of the hardware, as we talk, dropped recently.
Yes.
So it's not big surprise that customers, even those that were willing to be equipped, it was not economical equation. But now this has changed. But in 5 years, I probably we will not be talking so much about 3D anymore because it's going to be obvious. So you only talk about things that are new. Or different, etc. But in 5 years, is no way you're going to use a 2D sensor to measure a 3D problem. So we're going to be the 3D, let's say, perception is going to be just a part of the broader computer vision, and very likely combine together or integrated in interesting use cases. We talk about in the past previously of some use cases like reading license plates with cameras and tracking the movement of the car with LiDAR, etc. So you're bringing the best of the two worlds. Yes. Because LiDAR is not going to read the license plate, but you can track.
So really complementing each other.
Very complementing each other and not so much novelty.
Yes.
In 5 years, it's going to be everywhere.
Right?
It's going to be everywhere. It's going to be super quick. And we are seeing that today. It's when I'm saying it's not the future, it's the present, is because we have already signed very big contracts with customers that are deploying at scale. So it's happening today.
Nice. So probably we should do another podcast in 5 years and check where we are, right? Great. Okay. And the last question, which is our signature question, it's more personal. And I would like to for you to pick a subject of your interest about the future. So imagine we are 30 to 50 years from now. That aspect of life that you choose has changed significantly, right? Tell us, how has this aspect of life changed, and what is the technology that you're using?
Yeah, it's a good question. It's always super hard to try to imagine what is going to happen or what's going to change. So I think it's Jeff Bezos, I'm not sure, but I think it's him that said it's easier to try to see what is not going to change.
Interesting.
And what is not going to change is human nature. And we were talking about generative AI or this stuff is going to be adopted or not. And we were talking about before on developers that even if they are able to develop, they prefer to ask the AI to develop for them. And that's human nature. If you can do something easier, quicker, with less effort, you're going to use it. And so the good luck we're seeing here is that if you are as as a user or as a person can do many of the things that require effort today. Without effort, you're going to adopt the technology. And one of the things I think is going to change a lot is the education itself.
Okay.
It's
how?
For example, our children today are writing less and less.
Yes.
They're still
handwriting.
They're handwriting less and less because they're using more and more computers or tablet or whatever, etc. Okay, that's good for their business, but it's a fact that because it has a lot of advantage. It's immediate, etc. You can modify easily, etc.
It's faster.
It's faster. The advantage of this digital world.
Yes.
So, are they going to still need professors or even go into school? At that time, why? Not necessarily. Either they don't need to learn or they think they don't need to learn because the information is accessible.
Right. Yes.
And you can use it. Not only you can get it, but you can use it.
Yes.
Not you and the AI.
Yes.
But you can. So why you need this?
Very
so if today it's already hard to say to a child, you need to learn this, even if you feel that it's useless, you still need to learn that. Imagine if it's even less useless.
Yes.
Even more useless
in the future.
In the future,
that
so
is
it's going to change a lot.
Yeah, such an interesting topic because so you're saying the education will be probably homeschooling of some sort, right? But also the standards and the actual content that you're learning will also change significantly. So probably the people doing today the curriculums, designing the curriculums and standardizing these tests and saying what is useful to do what, to go into what kind of school, that would all change.
That
right?
will change automatically. Yes. I don't know if it's homeschooling or not, but it will change. And then you can be optimist or pessimist. You can be optimist and saying this is going to free a lot more time for a child to do, other stuff and relationship, etc. Instead of, just learning something.
Yes.
And the pessimist is that they are not going to know a lot of things.
Right. That we know today. Exactly. Very interesting topic because one thing I can mention is that my first job was a teacher. So I used to be a teacher of languages actually. And so it's very close to heart, the topic of education. So, but I can totally see that the education, the format, the content, everything is going to change.
It's going to change,
Yeah. Thank you so much, Raul, for being here. And we hopefully will have you again in the podcast to see if what we predicted today is true, right? Okay, thank you so much.
Thank you.